Hello guys, today we're going to solve a sample problem in chapter 10 of thermodynamics and heat transfer. The heat transfer by convection. The sample problem is a 3-meter internal diameter spherical tank made of 1 centimeter thick stainless steel is used to store iced water at 0 degrees Celsius. The tank is located outdoors at 25 degrees Celsius, assuming the entire steel tank to be at 0 degrees Celsius, and thus the thermal resistance of the tank to be negligible. Determine the rate of heat transfer to the iced water in the tank and the amount of ice at 0 degrees Celsius that melts during a 24-hour period. The heat of fusion of water at atmospheric pressure is 337 333.7 kilojoules per kilogram, and the emissivity of the outer surface of the tank is zero point 0.6, and the convection heat transfer coefficient on the outer surface can be taken to be 30 watts per square meter degree Celsius. Assume the average surrounding surface temperature for radiation exchange to be 15 degrees Celsius. The given values are: diameter is equals to 3 meter, the surface temperature which is equals to 0 degrees Celsius, and the temperature of the fluid sufficiently far from the surface is equals to 25 degrees Celsius, and the time is equals to 24 hours, and the heat of fusion of water at atmospheric pressure is equals to 333.7 kilojoules per kilogram, and the emissivity is equals to zero point 0.6, and the heat transfer coefficient which is equals to 30 watts per square meter degree Celsius. The outer surface area of the spherical tank is expressed as surface area is equals to pi multiplied to the diameter raised to the power of 2. Plug in the values, we have pi is equals to 3.0 meter squared. So our area surface is equals to 28.27 square meter. Then the rates of heat transfer to the tank by convection and radiation become: convection heat transfer equals to convection heat transfer coefficient multiplied to heat transfer surface area multiplied to the difference between temperature of the fluids and the temperature of the surface. Plug in the values, we have 30 watts per meter square degree Celsius multiplied to 28.27 square meter multiplied to 25 degrees Celsius minus 0 degrees Celsius. So cancel out the same units, we have convection heat transfer is equals to 21,202.5 watts. In radiation heat transfer, we have temperature of the surrounding is equals to 25 degrees Celsius plus 273 is equals to 298 Kelvin. And the surface temperature which is equals to 0 degree Celsius plus 273 is equals to 273 Kelvin. So heat radiation transfer is equals to emissivity multiplied to heat transfer surface area multiplied to the constant of proportionality between the two properties multiplied to the difference between temperature of the surroundings raised to the power of 4 and temperature of the surface raised to the power of 4. Plug in the values, we have 0 0.6 multiplied to 28.27 meters squared multiplied to 5.67 times 10 raised to the power of negative 8 watts per square meter Kelvin raised to the power of 4. Then multiply to the quantity of 298 Kelvin raised to the power of 4 minus 273 raised to the power of 4. Then crush out the same units, we have radiation heat transfer is equals to 2242.39 watts. The total rate of heat transfer is equals to convection heat transfer added to the radiation heat transfer. Plug in the values, we have 21,202.5 watts plus 22,242.39 watts, which is our total rate of heat transfer is equals to 23,444.88 watts. Next, the amount of heat transferred during a 24-hour period is expressed as the rate of heat transfer is equals to total rate of heat transfer multiplied to change of time. So plug in the units, we have 22.78. Plug in the values rather, we have 22.78 kilojoule per second multiplied to 24 times 3,600 seconds, which is equals to 2,025,638 kilowatts per second, or 2,025,638 kilojoules. Then the amount of ice that melts during this period becomes rate of heat transfer is equals to mass times the heat of fusion of water at atmospheric pressure. We rearrange the formula since the mass is unknown. We have mass of ice is equals to the rate of heat transfer over the heat of fusion of water at atmospheric temperature. Then plug in the values, we have 2,025,638 kilojoules over 333.7 kilojoules per kilogram. Then crush out the units, we have the mass is equals to 6,070.238 kilograms. So that's all for today, guys. Thank you for watching and God bless us all.